Hello and welcome back to Azure Terraformer. Today is the day that we take our Minecraft Bedrock server and we take it to the next level. No longer will it be a pet where if it goes down, we worry ourselves and try and nurse it back to health. No. We are going to pop it in the head and spin up a new one. The way that we can do that, because Minecraft is a stateful service, meaning it has a database and it maintains its own state in that database, we will have to find a persistent storage strategy that is going to meet Minecraft's needs. Now, Minecraft can't just change its database to use one of the many databases that Azure has to offer, SQL DB, Cosmos DB, Cassandra, whatever, you name it. No, Minecraft is third-party software and it has its own limitations and its own requirements. And we have to abide by those constraints. And so the way that, looking at how Minecraft stores its database, it maintains a local database on the file system. Great. Not a lot of options there. So when you think about file system options on Azure or in the cloud in general, it's not the best way to do a database. So how do we attack this problem? On Azure, we have something called managed disks. We can store the database onto a managed disk, onto a data disk, and if the VM crashes, we can reattach the disk and it'll be back up and running. That's not the best option, because what happens if that disk fails? That disk doesn't necessarily have as much durability as other services that are out there. Azure has a service called Azure Storage. It's one of the oldest Azure services there is. But that's not a knock on it. It's one of the oldest because it's so foundational. And Azure Storage has many different flavors. There's files, there's queue, there's tables, there's blob. There may even be an SFTP option these days. I have to look into that. I'm a little out of date on that. So in terms of replicating a file system, Azure Files is the way to go. Now, why am I not going to use Azure Files? Well, Azure Files would require us to use SMB or CIFS protocol in order to mount that share drive. That requires opening port 445, which is a no-go for many securities experts out there. Another option is to use Azure Blob Storage, but to mount Azure Blob Storage as a file system. As you may know, Azure Blob Storage is where large blobs of data can be stored. You can store petabytes of data out on Azure Blob Storage. But the way that you interact with Azure Blob Storage is you use HTTP requests and responses. And that's done over HTTPS using SSL and 443 TLS, right? Not using port 445 as like a file share service would. So you don't have the OS level compatibility with legacy systems, but you do have all the goodness of an efficient, large file storage system. So Blob Storage for modern cloud native workloads where you can build it from scratch is the way to go by far. Azure Files for old school software that requires OS level file system access, you're kind of shoehorned into Azure Files itself. However, using some third-party software, I think this is officially supported by Microsoft, by the name of Blobfuse, we can take an Azure Blob Storage Account and mount one of its containers as as a local file system location within our virtual machine. And basically what's happening is the Blobfuse software is doing the translation or the adapter logic from the OS, who's looking at its file systems, and mapping that to HTTPS requests to upload and download files to Blob. So this can be a pretty cool alternative, because it gives you the simplicity of Azure Blob, but it also allows you to use 443 port and traditional TLS traffic, as opposed to opening up the file share port. So that's what we're going to do today. We're going to set up Azure Blob Storage using Blobfuse, mounted as a folder within our Linux machine, where Minecraft stores the world databases. So that's what we're going to do today. So the first thing that we have to do is we have to update our Packer template to include to install Blobfuse. So let's look at the manual for Blobfuse and see how we might install it. So this is the documentation on Microsoft's website for Blobfuse, and you can see here we've got some installation instructions where and right off the bat, I can key in on some Ubuntu instructions that I could use. So looks like I'm going to be doing a wget, a dpackage, and then some apt-get installs, and then finally one last apt-get install. Okay, so again, this is my runbook. I'm copying this and going to codify it into my Packer template. So in my Packer template, let's go look. This is pretty much where we left off last time. Okay, so I have all the things that I need to install Minecraft Bedrock, but I do not have any Blobfuse stuff going on in here whatsoever. So the first thing that I want to do is I want to get those Blobfuse specific requirements added to my code here. So I'm going to go grab the script, and let's see, where should I put it? I guess the last thing I should do is this chown. So I'm going to put it after I set up the Minecraft system cuddle service. Yeah, that should be good. That should be good. So we're just going to drop those installation commands. You saw them earlier: wget, dpackage, apt-get update. If there's an apt command, again, apt's like the interactive way of installing packages in Debian-based distro. Apt-get is the automation-based way. So here I'm just doing those commands that you saw earlier. Now, the way Blobfuse works is it needs a folder where Blobfuse is going to synchronize what's out in the Azure Blob container down to that local file. And so that folder I want to be where Minecraft stores the worlds. So in this case, Minecraft stores the worlds in the installation directory of Minecraft and in the worlds directory. So basically this entire folder, and this is usually part of a Minecraft backup strategy, where you take that worlds directory, you zip it up, and you drop it somewhere, and because that contains all of your world databases that you want to keep in case your server gets borked and you need to start from scratch. Now, Blobfuse does need a configuration file. So I'm going to go ahead and create a new file, and it's going to be called blobfuse config.yaml. And if we go look at the manual again, config, and actually a better place to look at the configuration file, I mean, they have some snippets out here in the documentation, but if you go to the GitHub repo, again, this link will be in the video. If you go to the GitHub repo for Fuse, Blobfuse, they have two really great examples down here. A little further, where is it? There we go. So this sample config right here is a good place to start. So I'm just gonna, and notice it's a YAML, and if I look at kind of how they run how Blobfuse's mounts, you pass in a config file name. So I could name this file whatever I want it to be. It doesn't have to be anything specific. So I'm just going to, oh gosh, what happened there? I'm going to drop this in here. And so this is kind of the default configuration. Now looking at this, we're not going to drain the ocean and all the bells and whistles. You can go read the manual, and I would highly suggest go check out. So the one that I took is a sample config file. They have like the full file here, which has all the things, and it has all of the documentation with very descriptive things about like what each thing does. But really, I'm not super concerned about that. So in my file, looking at this, there's a file cache path. Now the file cache, again, this is, if you read the Blobfuse documentation, you'll understand what's happening here. The Blobfuse is an agent that runs in the background that basically in the background as a background agent synchronizes downloading and uploading files to Azure Blob. Now it needs kind of a working directory, like a scratch pad, so to speak. So there's a folder that you mount the Azure Blob Storage to, and that's where like your application is gonna store files and read files from. But Blobfuse itself needs like a little temporary cache. They call it the file cache. Now there's depending on the Azure SKU and your Azure VMs, depending on your Azure VM SKU and your storage strategy for your virtual machine, there might be different options here, because if you have like some high performance SSD things enabled, there's probably better places to put this. There's like memory based locations that you can put this, but the default place for a Linux VM on Azure is just the temp directory. This directory gets deleted anytime your machine shuts down or deallocates. So do not save anything in here that's super important, okay? That's the important thing. So this is the directory that Blobfuse is just going to use for a temporary cache. It is not the directory on the file system where Minecraft server is going to be storing the files. So I can make up whatever folder I want in here. Minecraft, and then we'll just call this worlds. So again, I can create whatever folder structure I want in here. If my VM were to be deallocated and respun up, everything in this temp directory is going to be gone. So I need to be able to tolerate that in my script that starts at my virtual machine, my kind of last mile post provisioning. Okay. Now down at here, this is the AZ storage, and this is where I'm going to configure what the storage account I'm going to be using for my for Blobfuse, right? So what storage account? How does Blobfuse know where to download files from and upload files to? This is the configuration for that. So the account name is going to be important, the endpoint, the container that I sync as well, and then the mode. Now, if you go look at the documentation, I would highly recommend checking out the mode. Okay, so mode is right here. Control F is failing pretty miserably. So we have key, we have SAS, we have SPN, and we have MSI. So 3 of these 4 I recognize. I'll have to go, look at what SPN is. But if you have been around Azure long enough, you'll know the primary mode that people have used to access blob storage accounts, and that's using an access key. So key stands for access key. SAS stands for a secure access token, basically. And so that is a token that can be, you can set an expiration date on it and it'll expire. An access key never expires. So that's a big distinction there. Now, both of these options would require me to embed a secret somewhere on my virtual machine, so that either as an environment variable or like a file setting or something, so that some value in a file, such that the VM can go talk to the Blob Storage account. Not the most secure. Now on Azure, what we have is what's called an MSI, or a managed MSI, managed identity. That's what it is. It's not the Windows installers, okay? But with a managed identity, this is kind of like on AWS, where you have an IAM role. And you can assign an IAM role to an EC2, and that EC2 basically gets all the RBAC privileges of that IAM role implicitly. So a managed identity is essentially that. Like when we set up our VM, we will assign a managed identity to that VM, and you can assign multiple managed identities, just like on EC2, you can assign multiple IAM roles, I think. Such that each of those roles can encompass different privileges that VM may or may not need. So I think MSI is the way that I want to go, because I don't fancy dropping, an access key or anything like that on this VM. So I want to put MSI there. Now, if I put an MSI there, I definitely don't need the account key, so that goes away. Now, when we're setting up a Packer template, we also have to think in the future about, again, 90-10. Think in the future about that 10%. How am I going to make my life easier when I'm doing that last mile configuration to swoop in, change just the settings that I need very quickly, and get out and start the VM? So here, what I'm going to do is I'm going to put some placeholder values, some magic strings. So this is the Azure Storage Account name, all caps, underscores. This is just a made up string that I'm going to use to represent the storage account name. And this is going to allow me to very easily search and replace using bash for this magic string in this file, because you don't see it anywhere else in this file. Okay, that's what's magic about it. And I can go replace that with the actual storage account name that Terraform has after it's done provisioning that thing. So I'm going to do the same thing for my storage container name, because again, my Terraform is going to provision a container name as well. Okay, and so now the last thing that I need to do, that I've configured this, I've set up this YAML config, is I need to go drop this YAML file onto the machine and then copy it to the directory. So again, you'll recall the file provisioner, and then which puts it into that temp directory, which is a safe place to put things that are going to be temporary. And then the last thing that we're going to do is we're going to do a copy command to move that file out of the temp directory and into the Minecraft server users home folder, just in the root home folder, and that's where it is. Okay, so that's all that we're doing, and from a Packer standpoint, I think that we're done. So I think we should be pretty good. Let me go see. We do need to change the image that we're going to be targeting. We're not going to be doing a local image anymore. We're going to be going with a Blobfuse image. So I'm going to provision this, and let's go to here. I need to go to my directory. Okay. And now I'm going to go debug, if I could spell, debug.sh. And I'm going to run Packer. And we're going to set ourselves up a new Packer image that has Blobfuse installed with these placeholders set for us, ready to go to tell it what storage account that we want to use. Okay? So that's what we're baking into our Packer image. Okay? Now, moving on, from a Terraform standpoint, we're going to have to make some changes in Terraform. So we need, the first thing that we need is we need a storage account. Okay? So I'm going to create a new file here called storage.tf. Okay, so in my storage, now for the storage account, again, let's go to our provider documentation. Let's look at our storage account, and we're just going to set up a storage account, and it's going to be GRS, and we're just going to give it a funny name, and that's pretty much it. So right off the bat, there we go. I've got my storage account. I'm using the random string in there, and we've set up a storage account. Now, we also need a container. Now this is one of those legacy words, right? Because container, when Azure first came out back in 2009, 2010, container didn't have as much significance in terms of nomenclature as it does today. So an Azure storage container is a logical bucket. It's like basically like an S3 bucket, where it's a logical container where we can put files in blob storage. So here I'm just going to take this container and I'm going to go create a container that is going to store our Minecraft worlds. So again, access type is private. It's pointing at our main, storage account, and the name of the container is worlds, because it's going to store our Minecraft server worlds. Okay. Now, you will recall Blobfuse needs a managed identity. So I need to provision an identity for my virtual machine. Now, how can I do that? So if I go look at Linux virtual machine, okay, then I go look at, let's just search in this file for identity, okay? So there's an identity block. What's on this identity block? So on our identity block, we can specify a type. It can be a system assigned, a user assigned. That's it, I guess. I guess you could enable both. Interesting. If it is user assigned, then you're going to have to specify your identity ID. If it's system assigned, it'll just make one for you, and it's a little bit trickier because you'll have to wait until the VM's provisioned in order to be able to assign RBAC to that particular managed identity. It actually does create a managed identity. It's just a dynamic one, but a system assigned one is created dynamically immediately after the virtual machine resource is created. So by using a user assigned resource, a user assigned managed ID, it means we can set up a managed identity that we reuse across like any VM that needs this credentials before the VM is provisioned, and it's not tightly coupled to that VM. So I think that's the way that we want to go. So if we look for user assigned, and look at that, we have a resource that will create a user assigned identity. It's one of those resources that is really not that crazy. There's not a lot going on in there, so it's not very hard to work with, but you just have to understand the concept of it. So here I've got a user assigned identity. It's going to go into a resource group in a region. I'm going to give it a name, which is going to be dynamic. So we need to assign a role assignment to this managed identity to allow it to read the blob storage data. So if we go look at our documentation here, in Azure we can create role assignments. This is kind of like an IAM access policy where you basically, and we're using a built-in role definition. You can create custom role definitions, right? So we don't want a reader. We actually want to use a specific role, which is going to be very, very narrow to just what this needs to do. And so this managed identity, all it needs to do is be able to, own the data within the storage account. So that means it can't access the keys and it can't do all those things, but it can create, read, update, delete the data on this storage account. Only this storage account. Not all storage accounts, not all subscriptions, just this one storage account. So it's a very narrow role assignment in this case, okay? And then what we have to do we've got our identity. Now with our VM, I think we have to attach that managed identity to the VM. So let's go check our VM module, and we're using Linux public. And if you recall, there was a block on the VM that was, I think it was just called identity. Yeah. So if we go and add a new block, and it's going to be called identity, and we're going to set the type equal to user assigned, and then we're going to set the identity IDs, and there's some IntelliSense, so that works. And then we're going to create a new variable called the managed ID, and that's pretty much it. So this is going to attach the user assigned identity to our virtual machine. We just need to declare a new variable called managed ID, type string, and pass in a value to our module. So luckily we already have the managed ID created. So we just need to go to our user assigned identity and then pass in the ID. And let's go add that there. Okay, wonderful. Okay, so now we need to modify our post provisioner script. So in the previous episode, we created a very simple script that just started and enabled and started the Minecraft service. Yeah. So what we're going to do is I'm going to change this just from Minecraft post-prod. I'm going to call this Blobfuse setup because we're no longer just setting up Minecraft. We are setting up Blobfuse, doing a bunch of stuff. So I'm going to change that in there. Okay. Now, one of the things that we need to do is we need to pass in a couple values into this script because this script is going to run, and what we want this script to do is inside of our home, like inside of this file, sorry, that's the wrong file. Inside of this file, we want it to replace this magic string with the storage account name. and we wanted to replace this magic string with the storage container name. Now we can do that with a command in Linux called sed, and we can do sed I, and then we have to use single quotes s at, and then separate using at, and then close quote, and then we'll use an environment variable storage account name, and then then we just close that off with the at symbol, and then we specify the file that we want to replace. So the sed, I highly recommend you go check out the sed syntax. Basically, this is what we're looking for. This is the string that we're going to replace every occurrence of this thing. Okay, so now if I take this and I put it here, I change this to container, and then I change this to storage account, storage container name, we can swap it out. Okay. Now, another thing that we need to do is in our temp directory, if you recall, we configured Blobfuse to use temp Minecraft worlds. Remember, when we spin up a new virtual machine, we can't expect that temp will have this folder. So this script, this post provisioner script, has to make sure that folder exists. So let me go grab that folder path, and in here we're just going to do a makedir -p on that path, and that's going to ensure that, okay, we just booted the machine, let's make sure that folder is there, and that way when Blobfuse runs, we will be able to its file cache will have the location that it needs to go into. Now the next thing that I'm going to do, now that I've got the Blobfuse configuration updated with my storage account, and because my VMs are already set up with my managed identity, and that managed identity is already configured to be able to talk to Azure, we should be good to go. Right, so now I'm going to use the Blobfuse command to mount the path to my storage account. And the way you do this is the executable is Blobfuse2, the verb is mount, the next parameter is the folder that you want to mount. So this is my Minecraft server, Minecraft, Bedrock, and then the worlds folder in there. And then the next thing that I'm going to pass in is where my config file is. And this is in a very specific location. It's in the root of my MC server, because that's where Packer put it, right? Blobfuse config.yaml. Okay, so now after this command, we should have the Blobfuse config updated. The temporary folder for the Minecraft worlds is there, and we've mounted the Azure storage container down to this specific local path on our file system. So now we're ready to kind of get Minecraft up and running here. So what I've noticed with Minecraft is, for some reason, if you use the default level name, it will override what the values in your data. So what I would recommend is changing the default. And so in the server properties of Minecraft, so I have to go to Minecraft Bedrock, and then go to server.properties. What I want to change is the Bedrock level. This is the default value for the world, essentially. And I'm just going to give it a name that's unique, that's different. Azure Terraformer. We'll just throw that in there, okay? And I think I can probably get away with that. Okay. And then let's just sleep for 30 seconds while we wait for the files to be downloaded from Azure Blob Storage. And then once those files are all downloaded, let's make sure that our Minecraft server user has access to those files by running chown again recursively on that user's home directory. Now remember, the Minecraft installation folder is in this home directory, and that Minecraft installation directory has the world's directory, which we just synchronized with the Blob Storage account. So the first time that this VM gets spun up, that folder will be empty. The Blob Storage account will be empty, okay? But the second time that this spins up, there will be stuff in Blob Storage that will be brought down, and we want to make sure that our MC server owns all of those files so that it doesn't have any problems when Minecraft actually gets started and going. Okay, so that's what we're doing here. So now this all works great except for one little problem. How do we get the storage account and the storage container name into this file from Terraform? Because Terraform provisions these things in this file here, storage.tf. Now that is done with a special Terraform technique called templatefile. So templatefile is just like our file function in Terraform, except templatefile it allows us to pass in parameters. Templatefile allows us to pass in parameters from our Terraform code. So in this case, just to make things like ridiculously simple, I'm gonna add some spaces here so I can see where all the things are. So after the parameter of where the file is, it's just like the file function, except it takes some additional things. So after that initial parameter, we can pass in a block of our own dynamic parameters. So the way that you define this block is using a curly braces block here, and then you create the name. So basically this is kind of like a map. So I'm going to create the name of the variable that I'm going to pass into this templated file, and then I'm going to pass in the value. And this is some funky syntax, but it will work. So now I need the Azure Storage Account name. I have a resource called Azure Storage Account .main.name, and that's going to get passed in to the file as a special variable called storage account name. Okay. Now, again, continuing my map, I'm going to pass in another one called storage container name, and this I'm going to set to an interpolated value using the Azure RM storage container .worlds.name. Okay, and then that will basically pass in the container name. So now I have template file, I have the file that I want to template, and then I'm passing in two parameters to that file. Okay, that's what's going on here. Okay. Now, how do I use these values after they're passed into the file by Terraform? So what Terraform is going to do is basically Terraform allows you to use these variable names as special values within this file. And what it's going to do is when this template file function is processed, it's going to go scoop up the contents of this file as a string, and then it's going to do a search and replace to replace these special variables with the string that it interpolates in this value here. Okay, so this is an HCL reference. This is a template file parameter name. This is an HCL reference to our container. This is the template file parameter name that's going to store it. So it's really simple, and there's a reason why I gave these kind of different names, right? So inside this file, when we're inside the script itself, this is the script that we're going to use template. We can go grab the parameters just by using this Terraform syntax, $squiggly storage account name. Now notice we're not using HCL syntax. We're not referencing a resource. We're not referencing a reference name and then an attribute on those resources. The string interpolation is only giving us access to the parameters that we pass in. So any parameter that you need, it has to be declared and the value set in the template file settings, which I've done for the 2 that I need. I only need 2. And so here I'm just going to echo these, and then what I'm going to do is I'm going to use standard bash, and I'm going to save those values to temporary environment variables, storage account name, storage container name, and that is how we're going to get the values out of the resources that Terraform provisioned into our virtual machine extension script that's going to run when our server starts up for the very first time. So I think that's it. Like we're ready to go. We're ready to run apply. Let's see if anything breaks. I may have made some mistakes. We'll find out soon enough. So we have a new Packer image. I probably need to use that Packer image version 4. Okay, and it has to be 1.04, and it has to be Blobfuse. So again, when we ran our Packer, we're building to this image name with this version. So if we want that version and that image name, we have to give the correct image name and the version name. And there we go. And so here I'm just gonna tick and tie these a little bit. I'm gonna call that Blobfuse, and then we'll fix the references. And this is gonna be Blobfuse, and this is gonna be Blobfuse. And what other references am I missing? I thought there was another local. Oh yeah, the reference to the image ID. My bad. Okay, there we go. So now let's run. Okay, looks like we're done. So let's go interrogate our environment. First, I'm going to check out the virtual machine extension to see if anything nasty happened. So enable succeeded. Storage account name, looks like it got that correctly. The container, it got that correctly. I don't think that's anything to worry about. I think that's kind of normal. We created the symlink and we started the service. Okay, let's go check out our storage account, see if there's anything out in the storage account. And there's our AZTF. Remember, I named the world AZTF, and here's our database. Again, it's a file system based database. This is looking pretty good. This is for our first time. I was kind of expecting to have to do some diagnostics here, but this is looking so far so good. Last little test. Let's use the Bastion admin user from key vault. Pull the right key vault. Pull the right key, and let's go check. Let's just do some on VM interrogation. Bada bing, bada boom. All right. So first thing we're going to do is check the service. system cutl status MC bedrock. That's positive. Now we're going to check the temp directory. So we have Minecraft, Minecraft, CD worlds. So this is what Blobfuse is using for temporary storage, I guess. And it's super temporary. There's nothing in there. Because if I go to the home, MC server, Minecraft, bedrock worlds, and then we go to AZT. Now notice AZTF is kind of highlighted green. I noticed with Blobfuse, whenever you mount a folder to a folder with Blobfuse, it has that green background to it. So I don't know if that's like a symlink. If you know what that is or what's causing that in Linux, post that in the comments below. I'd love to hear why that is the case. So let's go to cdaztf. Let's go to ls-l. So here's our files that are out there. There's also a db folder, ls-l. All right, so we can see the files aren't very big, but nobody's connected to the server yet. So now let's try that. So I'm satisfied with my interrogation of the environment. Let's go grab the public IP address and connect to this old bird. All right, let's connect and see if we can test the persistent state. So I'm gonna go and I'm gonna build a house, okay, in this environment. And we're gonna see if that house is still there. Okay, so let's go try and look and see if there's anything new on the storage account. So there's a 00005 LDB, which looks relatively new. Doesn't look like this has changed much, or any of these files here. So let's go ahead and delete the VM. Okay, the VM is deleted. Let's go refresh, make sure it's all gone. I'm still seeing the VM. I'm sure I'll get little errors in these panels. Yeah, there you go. There's a little bit of a delay sometimes. Waiting for stuff to clear out of here. Okay, so my storage account is still here. I still have my stuff. And my VM is dead. So now what we're gonna do is we're gonna rerun Terraform. We're just gonna run Terraform apply. Terraform is gonna detect that my VM is gone, and it's gonna try and recreate it. It's going to attach the managed identity. It's going to create a new NIC, a new disk, a new public IP address. You can see that, and a new virtual machine extension. that's going to run our same virtual machine script, which is right here. Now, this virtual machine script is going to do exactly what we did last time, except this time when we run this Blobfuse mount, this worlds directory out in Blob Storage is actually going to have files that are going to get synced down to our Minecraft server. And so this is where we're going to wait for a few seconds, and then we're going to start the Minecraft service once we give it a little bit of time to synchronize the files. Of course, our Minecraft database is not that big. I think it was 250K or something like that. So it's not going to be that big of a deal to synchronize those files. So it should be pretty much instantaneously, but we're just, I guess, overly cautious, let's say. So let's wait for this to finish. Okay, so it's finished. The VM's back up. This script, again, should have run. Let's hit refresh. Let's go look at our VM. The VM has the same name, but you saw it was deleted. Let's go look at the extension, make sure nothing weird happened. Enable exceeded, storage account, worlds, symlink created. There we go. Let's go check its IP address. It may be the same IP address, and if all goes well, I should show up in that same basement hut that I created for myself, running away from that zombie. So we'll see. We'll see if this works. We're still waiting for the server. And here we are. I'm in my hut. So there you go. We have successfully converted our pet Minecraft server into a cattle Minecraft server, one that we can pop at any time in the head, pop it in the head, and recreate a new VM, point it at the same data store, and we are back and running with our Minecraft server with all of the things set up exactly the way that they left them previously. So that's it for this episode. We have been having a good time. Got to get that creeper explosion in there. We've been having a good time with Minecraft so far. I hope you've enjoyed this. I know this is a little bit of a break from Enterprise. I hope you can see how these lessons are applicable. And how you can use these techniques within the enterprise space, because the idea of taking a third-party software that has persistent storage, that needs local file system storage for its own proprietary way of maintaining state, that's not a unique concept to Minecraft. Okay, there's a lot of third-party software that does that, and so this technique can work in those situations. We also learned about the difference between the custom script extension and just having a flat file that we load that we cannot dynamically customize in any way really, and the template file technique where we can take outputs of our Terraform apply, things that we are provisioning, our storage account and our storage container, and pipe those into the script, a bash script that runs on our virtual machine after the virtual machine's been spun up. So these are pretty advanced concepts, and when you stitch it all together, you have the 90-20 rule being enforced. 90% of our operating system and application configuration is packaged into our virtual machine image thanks to Packer. Our Terraform maintains the infrastructure that we provision out into Azure, and we use that last mile using the virtual machine extension technique to just swoop in, change a couple of little values, and start up our service. And it works brilliantly. So I hope you really enjoyed this series. Let me know about what direction you'd like me to take in the future. If there's particular topics that you want me to hit on. If I didn't go deep enough in certain areas, please let me know. I'd love to hear the feedback. I'd love to hear what you guys are thinking as I progress with this channel. So thanks a lot. Again, please hit like and subscribe. It really helps out the channel. I really appreciate it from the bottom of my heart. We'll see you next time here on Azure Terraform. Have a good one.